It's Mike here, and today, mini human brains, all of the ethical concerns around those, as well as the motivations in terms of health research and other research for why scientists are doing that. We're also going to be looking into putting human brain cells and these mini brains into animals. Yes, this is definitely a little bit of a departure from my normal videos, though we're still covering health and animal ethics a little bit, but I figured it's also Halloween season, spooky season, and frankly, or should I say Frankensteinly, nobody that I've talked to about this in my real life really knew much about this at all, if not anything about this. And so I just want to spread the word about this. And there's just been so many new discoveries in this area, new concerns, how AI and this intersect as well. It's all fascinating. I'm not going to push any opinions on anybody. You can come to your own conclusions on this. It's going to be more informative, but let's just go. All right, so the main thing that we're talking about here is human brain organoids. These are grown from human stem cells. They can take stem cells that are adult stem cells and revert them back to pluripotent stem cells, which are the ones that you would get from a fetus, but we don't need to do that anymore. And then you can give them signals to become brain tissue. And we're seeing these things grow to about 3 or 4 millimeters in size, and they might have about 10,000 brain cells. And they have been kept alive for as long as 800 or 900 days. We're talking a couple years. And this stuff is pretty spooky. I mean, after they're kept alive for a few months, over half of them tend to grow these little proto eyeballs, which can detect some light. So depending on whether they're exposed to bright light or darkness, we can see different brain signatures for those. And then it depends on what environment and what stimulus they're given as to what part of the brain they will mimic. And so you might get one that looks like a prefrontal cortex or one that looks more like a hippocampus. But some researchers are getting the structure to be more accurate, like a real brain, by giving a sequence of chemical signals, more like normal development. You can see here, kind of looks like a floppy piece of fungi. Improvements. But because they're just grown in a petri dish or a jar or whatever, they don't have vascularity, they don't have a blood supply going into the brain, and so they're limited in how much they can grow. However, research on this is changing, and my bet is that they're going to be able to get some more nutrient flow and increase the size of these in coming years. And we've also seen these things literally connect to each other through little bridges of neurons and communicate with each other and send signals, sync up. It's pretty wild. Now, at this point, you might be disturbed or curious or equal parts both of those and wondering, why the heck are they even doing this? And one of the major motivators for this is health research. This is how it's all justified, essentially. These are being studied in the area of neurodevelopmental and neurodegenerative diseases like Zika, microencephaly, as well as things like ALS and Alzheimer's. And as an ALS researcher said, there's a possibility to take stem cells from a patient with a condition such as ALS or Alzheimer's and essentially build an avatar mini brain of that patient to investigate possible treatments or model how their disease will progress. And another motivator, and ones that vegans will like in a bittersweet way, because it also has potential risks of its own, is that it can replace animal testing and perhaps be more accurate than animal testing. For example, roughly 99% of drugs for Alzheimer's that were developed in animals fail in humans. So as this paper mentions, organoid platforms may reduce the reliance on animal models and associated costs, therefore proving to be more ethical and economical. We'll get into the ethics soon. And I will say this is also ushering in a new era of animal testing with human brain organoids or cells, which we'll get into, which of course means it's not just getting rid of animal testing, but researchers have made some good discoveries so far, which include making discoveries about genes connected to autism, and they've also made discoveries for brain cancer. They took different people's little brain organoids and they gave them both cancer, and then they treated them both with chemotherapy, and in some people it would work and in some people it would not, so we can learn about that more and potentially help cure cancer. They also made a mini brain from people with a rare brain disorder called Rett syndrome, and they used an experimental drug and normalized their otherwise very abnormal brain patterns to an extent. And they're looking at these in terms of Alzheimer's from several angles. We're talking about those hallmarks such as tau tangles, amyloid beta aggregation, neuroinflammation, and more. And they're also trying to study these for space travel. They threw some little mini brains into space and found that they matured faster, but they still don't know why. Maybe if my brain developed in space, I would have a more mature sense of humor, but it didn't. So health is one angle that these are being developed from, but another angle has to do with the goal of technology, and I think is going to get probably a lot more funding, and that is creating what is known as wetware, a term that just makes me feel a little icky sticky. But we're talking about hooking these organoids up to computers, to electronics, or to hardware, and making essentially either cyborgs or using these brains to do computing. Why would somebody want to do that? Perhaps the most valiant argument for this has to do with the environment between AI and blockchain. We're starting to see a reasonably large environmental footprint from these technologies and computing itself. As the UN mentioned on this environmental topic, quote, a request made through ChatGPT, an AI-based virtual assistant, consumes 10 times the electricity of a standard Google search. And from this report, globally AI-related infrastructure may soon consume 6 times more water than Denmark, which has 6 million people. And this is mainly data center cooling and then also water usage for creating the power from power plants. And because of evolution and scarcity of resources, the human brain is incredibly efficient at calculating things and just existing and having computing power. And so our brain uses about 20 watts of electricity. We're talking about a couple LED light bulbs, but looking to a computer that would have the equivalent power and ability and memory, we're talking about something that would need 8 million watts. So what's that? Like 400,000 times as inefficient. And interestingly, this is rumored to be the original plot of The Matrix, because you might remember that humans were plugged into the Matrix by those robots to be harvested for electricity as batteries, but as you can tell by the brain usage, humans do not make very much electricity. That doesn't make much sense. And while I can't find verification of this anywhere, the theory is that the original idea was that humans were being plugged in so their brains could also be used for computing power, but then that was too abstract for an audience 20 years ago or however long that came out. But apparently we're as bad as those robots anyway, because in multiple scenarios here, we've now created little mini brain matrix situations. The most simple one that some people might have heard of is that they plugged a mini brain in to play Pong, and what they did was essentially, if it missed the ball, they would give it this scattered, disorganized electrical signal, but if it hit the ball, it would give it a nice orderly signal. And so they essentially trained it to play Pong, and it learned in less iterations than AI. The mini brain took 15 rallies to get where AI took 5,000 rallies to get to. But that's not that much of a matrix, and it's quite simple. It's getting a little bit more complicated though, because just 4 weeks ago, you can see this video was posted by one of these companies, and they hooked a mini brain up to a small butterfly so it could sort of fly around in this virtual world. I don't know how much of that virtual world it's seeing, but they are giving it sensory input back, and it's controlling the butterfly.
It's as if the brain itself is living within this simulated world.
Does it really know what's going on? Unlikely, based off the structure and signals we're seeing in the brains at this point, and we'll talk about how these mini brains compare to human development a little later on in the ethical section. And now for a quick brain easing break with today's sponsor, Seeds DS01 Daily Symbiotic, which is a prebiotic and a probiotic, and each one of these little guys has 53.6 billion active bacterial cell units, and from 24 different strains, which are scientifically shown to support various areas of health like gut barrier, gut immunity, digestive health, heart health, and skin health, which continually blows my mind, which is why I want to cover that today. There have been multiple randomized controlled trials on strains that are in seed for people with atopic dermatitis, aka eczema. And there was this one that was on adults with eczema, and giving seed improved their condition, as well as this study on young people with eczema as well. And you can see this chart for the placebo group versus the probiotic group, and blammo, they're doing way better, really getting out of the diagnosis in many cases. So that's the skin knee on seed. But yeah, Lindy and I have been taking seed since 2021 and loving it, especially Lindy. You know, we always take it with us when we travel, but yeah, if you would like to try it, feel free to click the link below and use the code Mike25 for 25% off your first month supply. All right, back to mini brains. But they haven't just been plugging these guys into virtual worlds, they've also been plugging them into robots, because why not create cyborgs, I guess? Nothing could go wrong there. A while back, we had this sort of 4-legged spider-ish robot hooked up to one, and that's the brain controlling it. Does it really know what's going on? No, but is it moving it around? Yes. Also, more recently, a group of researchers in Tianjin, China, have hooked up a little mini brain to this robot here, and allegedly it can control the arms. They say that using this Metabot open source chip, which allowed it to interpret external electrical signals, and that it's allegedly capable of directing robotic systems to navigate environments and grip objects after simulation training sessions, according to Popular Science. And from the front, it looks just like a normal little robot with that black screen face, but then, you rotate it, turn it around, and it's a meatball on a stick kind of situation.
Turn your ass back around.
And in terms of computation, a somewhat more recent preprint, so not peer-reviewed, but likely to be peer-reviewed, researchers had their mini brain solve nonlinear equations using what they call Brainoware, which is just their version of that brain hardware. And what that is essentially you have the brain hitting electrodes, and so they're able to get electrical signals, at least from the surface of the brain, and transmit them. They said that in 4 training sessions, it was equivalent in calculation ability to an AI with 50 sessions. However, AI can do a ton of sessions really, really fast. This was like 1 session per day or something like that. So not comparable at this point, but with more advanced electrode structures and them figuring more out, I feel like it's gonna get there. And of course, scientists are scientists, so they have to do weird stuff like try and gene edit them so that they're more like Neanderthals and then compare them. And yeah, it turns out the Neanderthal mini brains have a little bit bumpier of surfaces and actually mature a bit faster as well. And so researchers are gonna kind of put those 2 mini brains head to head and see who's smarter. It's like, haven't we done enough to Neanderthals? We essentially drove them to extinction for those that didn't interbreed with us. And now we're like, oh, we're gonna recreate your brain to show that you're stupider than us. However, there are some indications that they were smarter than us in some ways in terms of brain size, etc. Another idea that's been floated with these floating mini brains is the idea of upgrading your own brain by, once this becomes a bit more advanced, grow a section of your own brain that's trained in a certain way, perhaps for mathematics, and then have it attached to your own head so you can be a genius. Sometimes don't you want to just go lay in a nice field and just like spread some dirt on your face and escape all of this? And with all this brain matter growing everywhere, do you know who would really like this research?
The late great Hannibal Lecter. He's a wonderful man.
And then there's a whole nother area of this where we get into the animal testing where they're either growing these mini brains and transplanting them into rodents, or they are infusing rodents with human brain cells from a young age, putting human level brains in animals. What could go wrong? Did nobody watch Planet of the Apes? That was a virus. In one study, they transplanted a human mini brain into a baby rat, and over the course of it growing, the brain grew to 9 times its original size, and it grew larger and more active than they do in petri dishes, without stimulation from an actual brain in a living organism. And the brain also integrated itself quite well, connecting itself deeply into the brain. So that's wild. And the question becomes, why are they trying to do this? Are they just trying to create weird human-animal hybrids? Like Full Metal Alchemist is like, hold my beer. Well, perhaps the largest motivation for this is essentially making little stroke patches to repair the brain. And they have done just that in mice, essentially taking mice, giving them strokes, gotta love animal research, and then just implanting these human mini brains, and they do repair the damaged area. Or as they say, it was, quote, conducive to restoring the brain injury of the host. But it doesn't have to be a full human mini brain implanted into mice. You can actually take certain human cells, like glial brain cells, which are more structural, and implant those into mice when they're still embryos, and as they grow, you get a mouse that is smarter, faster, stronger. Okay, they didn't test strength. But yeah, these mice did perform better, and those human brain cells just spread all the way throughout their brain, which is wild. And I feel like we're definitely headed in that direction of creating like Rocket from Guardians of the Galaxy, the raccoon that has human level intelligence. Like, how far away are we from that actually? And this actually brings us to the ethics. It has people asking, quote, are rats with human brain cells still just rats? So we'll talk about the animal-related ethics here in a bit, but we have to even talk about human-related ethics, because at what point do you get these brains equaling a whole nother human in terms of their ability to perceive and suffer. If you're looking at comparing these mini brains to humans, we're talking about, if they are alive for longer, having the same brain signatures as like a 7 or 8 month old fetus. And you probably know that artificial intelligence, AI, is becoming a hotter topic in terms of potential ethical issues as it becomes more advanced. But have you heard of organoid intelligence, or OI? Well, now you have. So I just wonder, where does the problem arise? Clearly, it's not a single brain cell. It's not 10. It's not 100. Is it the 10,000 that we're at? It doesn't look like it yet, but what if we get to 100,000, a million, etc.? And then what if the hardware gets way better to interface with these mini brains so that they have, 8K vision and like a haptic robot suit and are just a full-on cyborg? And it actually is the case that we've had at least one paper refer to these mini brains as sentient, which definitely rung some alarm bells. However, if you actually read the paper, it's talking about sentient just as the ability to respond to stimulus and make memories from those responses. In the case of that Pong game, it did. But this is not a higher level sentience than some like super simple microscopic organisms that don't get ethical consideration. So yeah, there's a fine line between the ability to respond and then the ability to fully suffer and realize that suffering. And so that's what we're gonna have to be tracking as time goes on. And we might end up using the same technology that they use on people in comas to see if they're brain dead and adapt new technologies for that. And then we have whole issues about legal rights. Who owns the brain organoid? Is it the person who did the donation or the person who grew it? And in terms of personhood, from the Oxford Journal of Law and Biosciences, quote, human brain organoids are not equivalent to a fetus or even to an embryo, since unlike them, human brain organoids do not have the potential to develop into a whole human organism. But I still have to counter with that, decades in the future when the connection to the world is way more advanced, I think that argument is going to be a lot harder to make. Like, they might not be a classically defined human, but they might have the same level of awareness, intelligence, and ability to suffer. Either way, the progress of consciousness in these mini brains needs to be heavily monitored, and we need to keep an eye on it, and we need to have laws around it, and we need to keep industry out of making those laws, because we've seen that go wrong in the past and currently. A good example, there's no federal law governing poultry being raised on a farm. The chicken industry has lobbied for both exemptions from laws that might protect chickens from cruel treatment and for affirmative laws protecting the industry. So yeah, we have chickens whose newborns perform better than human newborns in terms of math and other tests, having absolutely no protection despite being sentient and able to suffer and all of that federally on farms. So what can we expect with this? We'll see. So along those same lines, in terms of animal ethics and putting human brains in animals, I think it's interesting to see if people then start caring about the animals, because generally people aren't caring about these animals. Despite the Cambridge Declaration on Consciousness, which was signed by Stephen Hawking and many others, talking about how a lot of animals exhibit high levels of sentience and ability to suffer and straight up consciousness. And so while I agree adding more human neurons and increasing the intelligence and memory, etc., of certain animals might increase their ability to suffer, they already have that ability. And even with that ability, we're deciding to raise and slaughter 80 billion land animals and hundreds of billions of marine animals for food. So let's try and not cause suffering in all of these sentient beings, the ones that exist and the ones that could be developed. In the end, if I had to guess, you probably didn't know everything in this video that I just said about mini brains. Maybe a couple of you did. A lot of people, like I said, don't even know that these exist, that this research is going on. And we just have this massive scale essentially here. That's the issue that I see, where on one side, we're trying to improve humanity, fight diseases, lower the environmental impact of AI, for example. But then on the other side, we just have this Pandora's box of potentially creating, a whole nother strain of cyborg brains that could potentially suffer quite a lot as well and be trapped in matrix situations for years. So what's the future to say about this? I mean, are we going to have mini brains behind the wheels driving our cars and trucks, or is that just going to be AI? Are these mini brains going to be put into robots that are in the service industry? Where is this going? How much are we gonna let happen? These are big questions. But if you are concerned about the sentience and the development of sentience in these, again, I just have to remind people that we do have sentient animals that we are not caring about. So please care about them more. And I do just want to credit two creators that have been following this closely that helped me research this video. And that is I'm Curious, IHM, on YouTube, as well as Bearbait Official on TikTok. And then of course, if you would like to try Seed's DS01 Daily Symbiotic, which doesn't have any mini brains involved with it at all, feel free to check the link below and use the code MIKE25 for 25% off your first month supply. And as usual, let me know down below what you think about all this. I know that everybody is gonna have a strong opinion or strong feeling about this, so just let it loose, I guess. People do that anyway in the YouTube comments. Anyway, feel free to like, subscribe, all that good stuff, and I'll see you in the next one. Thanks for watching.